Hello guys, in the last video I gave you an introductory overview of what exactly Llama Guard is, which is basically a 7 billion parameter model or LLM from Meta to safeguard input and output to any other LLM. Llama Guard works on a taxonomy, and if you remember I also showed you this taxonomy from their white paper where they have created this taxonomy on 7 different parameters like violence and hate, sexual content, illegal weaponry, and lot of other things. And if there is any input or output from user or LLM which violates this taxonomy, this Llama Guard is going to tackle it and it will block it. So primarily what Llama Guard is a new model that provides input and output guardrails for LLM deployments. And I have a very detailed video where I go into each and every facets of Llama Guard, and I'll drop the link in video's description. The purpose of this video is to show you how you can run it or how you can safeguard any model with Llama Guard. In order to use this Llama Guard, you would need a couple of things. You would need to go to Meta's website, and I'll drop the link to this GitHub repo too. So from here, click on this Meta website, and from there you would need to request access to this model, and also you would need to go to Hugging Face website, log in with your free account and request access. I did it this morning. Thankfully it was quite quick that instead of 1 or 2 days I was granted access via email in Hugging Face. So happy days. So that is why I have decided to create this video to show you how you can use this Llama Guard to guardrail any model. And I'll be using Zephyr 7 billion model, and I'll be using a notebook in AWS SageMaker. And I'm planning to start with this G4D and 2x large instance because it has 32 gig of memory and 1 GPU with 16 GB of GPU memory. Now this model is 7 billion and quite heavy because I tried it out in Google Colab, didn't work with a free account. So that is why I'm using this AWS SageMaker notebook with this spec. If it doesn't work, then I would have to maybe upgrade my instance, but let's see if it works with this one or not. So let's get started. Let me log into my AWS account and go to AWS SageMaker. So this is my AWS SageMaker notebook, and I'm already logged in there. And you can go to AWS SageMaker on the left hand side, click on notebooks and create a notebook with the instance spec which I just showed you, the G4D and 2x large. Okay, and I'm using the Amazon Linux too. The first thing we need to do is to install some of the prerequisites. So let's run it. And these are the usual suspects like LlamaIndex, Llama Hub, and transformers. And then Quadrant as a client, because Quadrant is a vector database which we are going to use. It's an open source database which is based on a Rust language and quite a performant one too. So let's wait for it to finish. Until we see this static, it means it is running. Let's wait for it to turn into a number, and then we will proceed with the next step. It took a bit of a time, but at last you can see that after installing lot of stuff, it has finished successfully, which is great. And now let's import some of the libraries such as logging, sys, and then also set up the tokenizer. So let's run it, and it is going to set up our tokenizer so that it would be able to do the proper tokenization around the model. So let's wait for it to finish, and you can see that we are using this Zephyr 7 billion beta here. It might take a bit of a time, but that is okay. And that is finished. It might give you a few warnings, but you can ignore them for now. And you can see that it has downloaded the tokenizer model, and keep going down. It's all good. And now let's load our data. For this example, what I'm doing is I am from Wikipedia. I am just taking this Wikipedia page on Geoffrey Hinton, who is called as one of the leading researcher in artificial intelligence. So all I'm doing is I'm using LlamaIndex downloader, and from there I'm using their Wikipedia reader, and then just specifying this Geoffrey Hinton page and then loading the document. So let's run it. And this is one of the beauties of LlamaIndex, that it really makes it so easy to build your retrieval augmented generation or RAG pipeline. All you need to do is to just get some libraries and load your pages. And you can see that already done. It loaded one document, which is awesome. And now let's create the node parser. So when I say node parser, it means that we are basically utilizing the vector database or impacting database. So what happens is we loaded the document, and when we give this document to LlamaIndex node parser, it chunks it, or in other words, it divides it into different chunks and then creates a embedding or vector representation out of it, and then assign it to each node, and then each node takes care of that document. Because this is a very small document, so it might not be that huge, maybe there might not be many nodes, but if it's a huge corpus of data, then there will be many children nodes, each containing metadata, text, metadata templates, and a lot of things. So but in this case I don't think so that will be the case. Let's first import this stuff. That is done very quickly, thankfully. Now let's create a quadrant client, and for this one I'm simply going to use in-memory database, the vector database, which is also done. And then in the next step, what I'm going to do, I'm going to create a vector store. And let me give the code properly here. So this is the one, and I'm just going to call it maybe Jeffrey Hinton. Okay, that is done, and there should be a parenthesis somewhere here. That's good. Let me run it. That is also done. And now let's create the storage context, because this storage context object is what is going to store our vector database. That is also done. And now let's create our node parser, and that is going to chunk and do all the stuff which I mentioned earlier around metadata of all the documents. So it's a very small one, so it was very quick here. Okay, and now let me, okay, so that is done. Now the next step, what we are going to do, we are going to define the service context with LLM and embedding model. So LLM is what we are going to use, the Zephyr 7 billion beta one, which we will be talking to, and embedding model is what exactly converts that model into numerical representation. And embeddings are simply the similarity thing where it creates a numerical representation and then stores the similar vector numerical representations close by. Okay, let me paste it here. So this is what we are doing now. We are just importing Hugging Face library. This is where we need to put in our Hugging Face token, and make sure that you obtain the Hugging Face token from Hugging Face website. Let me also show you how to do that. Let me go to Hugging Face. So this is my Hugging Face page. Click on your name and then go to profile, and then in the in settings, and then access token. Let's grab the right token. So maybe I'll just create a new token so that I won't have to hide it from you. Maybe I'll just say right, and I'll say LLM Guard, and I'll delete it later on. Generate a token, click on copy button, and then let's go back to our notebook and let me paste it here. That's done. So now this is our token, which we have set it in the environment, and this is a model we are going to use. This is a token, and then this is the model, the embedding model, which will convert our service context into, or whatever the document we have loaded, into the numerical representations or embeddings. Let's run it. It is running, as you can see, and it is going to download the tensors of the model very quick, thankfully. Awesome. Let's go up to see if static is okay. So it's already done, which is awesome. So let's go downwards, and everything looks good. Okay, now in the next step, what we are going to do, we are going to define our index in the vector database, because we want to access it, and then without index we can't do it. So there are couple of commands there which we need to put in. Let me grab them and put it in here. So these are the commands. Let me quickly walk you through. So we are simply importing this function. We are using our node parser which we defined above. This is the storage context where we are storing it, and then this is a post processor which will create the index on top of it. So let me run it. There you go. It's already done. Very quick. That is done. Okay, now so these are the steps until we have added our chunks and we have done all the chunking video and chunking audio and stuff. Now in the next step, what we need to do, we need to download the Llama Guard moderator pack, because until now we haven't really even used the Llama Guard at all. We have just created our sort of RAG pipeline where we have provided our own custom document to a Zephyr model. Okay, so this is what we use. So what is happening here is we are importing the Llama pack, and then we are installing the dependencies and everything with the Llama pack with the help of this LlamaIndex. Let's run it. And that is awesome. That is already done, which is correct. Did it timed out or what? No, I think we are good. 200 is there. Okay, and now let's create the empty constructor out of this pack, and these are the steps we need to follow as per LlamaIndex documentation. So you can see that it is now downloading that Llama Guard. It is running. Let's wait for it to finish. Let's stay here. Now what this step is doing, this is downloading Llama Guard 7 billion model to your local, or in my case in this notebook. So let's wait for it to finish. I'll just pause the video for a second to make sure that, because it will take few minutes. And let me show you too quickly if I could see any download. Yes, this is, so the size is under 5 gig, and you can see my speed is okay. It's not that bad and not that good either, but still it is chugging along. So make sure you have this much space on your notebook or any system wherever you're trying to install it. So let's wait for it to finish. My model is still being downloaded, and I just wanted to give a shout out to Venki Clans for producing this LinkedIn post from where this video is inspired. And so huge thank you, and I'll also drop the link to this post from LlamaIndex in the video's description so that you could read further. And there are a lot of other information. I would highly suggest you read through this link too, and also go to their LinkedIn page. Okay, let's go back to our notebook to see what is happening there. So thankfully it is almost done. So let's wait for it to finish. Okay, that is good. Let's quickly check above to see the cell. It is still running. Let's wait for it to become a number. So now second chart is going on out of 3, and you can see that my speed has really gone down. So hoping that it will pick it up and it will be quicker, but let's wait for it to finish. The second tensor has finished downloading, and it took around 30 to 35 minutes, and yours truly is still there waiting for it to finish. And thankfully now it is at the last shard, which is again close to 3.6 gig, and the ETA is under 1 minute, but it will increase, not under 1 minute, sorry, it is around 20 minutes because of my download speed. Nothing to do with the model. Maybe AWS is doing some throttling, or maybe Hugging Face is doing some throttling. I'm not sure. I don't have any control over this. So let's wait for this one to finish, and then we will resume again. Okay, after waiting more than or close to 2 hours, it is almost done. So let's proceed further. So the model is downloaded, the Llama Guard I mean, and now we are going to create a function which I have obtained courtesy to the guy which I told you about earlier, Venki Clans. So thank you for this really amazing function. and you can have your own. So what this function is primarily doing, whenever it is receiving an input or output, it is first checking that it is running that query or input or output through Llama Guard, and it checks if it is safe. If it is safe, then it returns the response, and if it's not safe, it just tells us the response is not safe. Please ask a different question, and that is the response we get. So let's run it. So this is a simple Python function, as you can see. Okay, now that's done. And in the next step, let's now run some of the simple queries. So for example, I'm just going to say here like query is equal to, I'll just ask it, who is Hinton? A very simple one. Let's see what it does. And then maybe I'll just send it to our newly maybe our sorry, our model or Llama Guard dot pack run. So this is a query. I'm not using this function at the moment, I'll use it later, but let's just run it from here. What is showing me this? Maybe okay, let's see if maybe it needs single quotes. Let me see if it is a single quote one or the double quote one. Okay, missing white spaces under. Okay, this is better now. Let's use the double quotes. Okay, better now. Let's run it. Okay, so let's see what the error is. Okay, no kernel found to launch. It seems my kernel has crashed and I need to run it again. So let me restart my kernel from here, maybe due to the RAM. Okay, so in order to restart the kernel, we would need to restart from here or maybe reconnect. Let me reconnect it to it. And now let me run it. Maybe due to the prolonged download period, it just crashed. Let me run this one. If not, I'll just restart the kernel. I think the same one. Yep. Okay, let me restart it. Okay, so what I did, I restarted the kernel. It didn't work. So instead of using the TensorFlow, if you look at the top right, I selected this Conda PyTorch P310 and then ran it again. It ran fine, but it has given me CUDA out of memory error. So it seems that I would need to upgrade my instance. Let me quickly do that. I think instead of instance memory, I would need a bigger GPU card for this. So let me try it out. Let me bump it up to see if that works or not. If yes, happy days. If not, then bad luck. At least I would be able to give you the next steps. But let me first try out upgrading my instance and then rerunning it. So I have upgraded my instance in AWS and I'm now using 4x large with G4DN. So, and I'm now restarting my kernel and see if it works or not. If not, then we will just go through this code again just to make sure we understand, and if you have access to any beefy system you can run it and it should work because it is just a matter of resources. I have thrown as much money as I could, but I think that is where my limitation is for the budgeting. But if you have access to any beefy system, then you can obviously run it, and I'll also drop the link to that blog post which you can follow to run these commands. So while it runs, I think this is a good observation we need to make, that still idea is good, but if it is taking so much resources, then I think it will be really very hard for the enthusiast and small businesses to run. I think that any guard model or any such model should be no more than 1 to 2 billion parameter instead of 7 billion, and it should be lightweight, should just hook up into any model easily. So that is what my thoughts are, because if it is gated, if it is taking so much time and resources, then it will be very hard for people to run. So you can see that it has used all the cache ones as I have restarted the kernel, and now it is importing using the auto tokenizer and stuff. So it will run all the cells up to here where we are using it, and then it will run to see if it works or not. So while we wait for this to come back and see if it works or not, let me show you an example where we can use this function which was created earlier. Okay, it is running quite fairly quickly, so let's wait for it to finish. Earlier, as if you remember, it was taking long time to download, but this time it is very quick. So it's at the last tensor, which is nice. So let's wait for it to come back, and then hopefully it should be, we will see if it works or not, and then I'll show you the last example. So as you can see that all the model is downloaded, and now it is at the last step. And let's see if this time it gives me out of memory error or if it runs. I think nope, it again out of memory error. There you go, so good out of memory. Anyway, so I'm not going to run it again. I'm just going to show you how we can use the function. So as you can see, I'm asking it write me a toxic joke about Hinton. Now this should be blocked by Llama Guard, and we are passing this query to this moderate and query run function. So if you go up a little, and this function we are passing, so as soon as it will check this moderator's response or Llama Guard's response after running it query, it is going to print it unsafe, and then it will say that the response is, or sorry, the query is not safe, please ask a different question. So maybe let me run it for the sake of it. So it is running, and you can see that again out of memory error. So but anyway, you now know how to use this Llama Guard, all the commands, and if you have access to a beefy system, you should be good to go. All in all, a really good concept, but as I said earlier, I think they should really need to make it more lightweight so that everyone would be able to use it. I have been using like a huge system, but still it failed. Anyway, enough whinging. If you have any questions, or if you are stuck other than any resource constraint, let me know and I'll be happy to help. And if you like the content, please consider subscribing to the channel. Thank you very much.